I did you notice I wasn't here last week?
I did. I showed up, but you weren't on. I figured it was the day after Christmas, so I figured you were having a good time with family.
That's exactly what happened, but I didn't know that I was having a good time with family, and that was until I realized I had missed it. So yeah, that was my excuse, but I didn't employ it personally. I was horrified.
Oh.
Yeah,
Well,
it's
it's a sign you're having a good time. Time just
yeah,
blows
no, no,
by.
it's interesting because I've been doing this. Uh, I treat it as an appointment, and that I have with other people, and so I have to appear as promised. And even though the promise goes out into the vacuum, uh, I still feel as if it is my duty to keep my promise, so I do. And so I didn't, and so I felt horrified.
Hi, sir.
Hi, Kate.
No
Welcome.
worries.
Welcome. Uh, Haris has been here many times, but Kate, I've never seen you here before.
Yeah,
You're new to my stage, right?
yes, I'm new.
Hi, Kate.
Right. Okay. So, to make this thing work, what the rules are basically ask me a question, I'll tell you no lies if I can help it.
Okay, sir. Can I ask about reincarnation?
Reincarnation. Uh,
Yeah,
uh, what country are you from?
I'm from India.
Uh-huh. So then that would make a lot of sense. That's a question that you would ask if you are from India. Uh, excuse me, I have a bit of a cold. Uh, so what is your question about reincarnation?
Reincarnation, you know that there is a scientist, Ivan Stephenson. He find out that 3,000 students remember their uh, birth, reincarnation.
Did you say that there was a scientist who found 3,000
Yeah,
students who had been
yes.
reincarnated? Is that right? Okay. So I can only speak from the science that I know
Okay.
uh, and have been taught in school, and not from personal experience. And I believe that reincarnation. So I'm going to say that I believe, okay, rather than I know, but I believe the reincarnation is part of a religion that I know it to be true, certainly. But I believe that it has never been established by science as being verifiably true. And are you saying that you know of a scientist who has verified that reincarnation has occurred?
Yes, Ian Stephenson.
And what is the evidence that the scientists provided?
Uh, uh, in young age, they can remember what their past life is. So
I'm sorry, I didn't understand that.
uh, they can understand. There are so many cases in India also. They can remember their past life. They
Right.
know where in the childrens know in past life they where they were born or something like that. There is Anne Frank.
And Frank? Who? Who?
Anne Frank.
And Frank is a person who wrote a book during World War II. I don't know who Anne Frank is.
Yes, a diary. Sure to.
Yes, I know the diary of Anne Frank, but since she hasn't answered, I'm not sure that we're talking about the same person. So, Kate, let me say, that, uh, uh, according to the science, as I understand it, and as the science that I've been taught, and as a science that I believe to be true. Uh, Reincarnation is not scientifically proven. It is, in fact, uh, generally, it's found in India, of course. Of course, that is certainly true. But I do not think that it is, at least Western science, as far as I know. So perhaps there is Eastern science that might validate what you're saying, but in Western science, it is not. It's not true. That's all I can say. Thank you for your question.
That was a good answer, actually.
Well, I'm modeling myself after Carl Sagan, right? What can I do? You know, what would Carl Sagan say, right? Right. So I'm trying. I'm trying. You
Well,
know.
I do have a question
Yeah.
that you had probably a few weeks ago now. Like, I was wondering if you could talk more about um, these filaments that we're finding out there in the structure of the universe, and,
Right.
and like, because like, when I think of filament, I think of like carbon filament and incandescent light bulbs, but I
Right.
imagine this is something on a much different kind of scale. So if we can talk about these
Certainly.
filaments.
The word filament is only by analogy, uh, and so that it gives you the idea that it's long and narrow, and
Oh,
and it also gives you the idea that perhaps it may have been stretched to produce that. That's also another uh, uh, idea that the word filaments types seems to arise. But the filaments in the universe are really nothing like that. They have nothing, no relationship. For one thing, they're millions of light years in width and billions of
oh,
light years in length.
oh, damn. Oh,
Oh,
okay.
damn. Yeah. So they're and so what you get so what a filament is in the universe is, imagine a galaxy like our own, which is 100,000 light years in diameter, and if you will, it's the part of the galaxy which extends beyond the horizon of the visible light, but in fact contains dark matter and gases, and so our own galaxy might be considered to be 300,000 light years. And imagine that there's
Hmm.
and imagine that there's another galaxy out there uh, named Andromeda, for example, and it's 2 million light years away, right? And imagine that those two galaxies are part of a string of galaxies that sort of stretch out for for millions, if not billions, of light years. And imagine, so you're counting a galaxy as part of a dot on the filament. So,
Oh,
so you
oh,
have thousands of galaxies forming a filament, and they talk about filaments and voids. So a void is where there's an absence of what? Of galaxies. Absence of galaxies. And does that mean absence of? No, it means just less. So so few that literally you can point to filaments and voids and use them in the same sentence as if they have any relationship to anything human beings could possibly imagine. But they're way beyond our imagination. They're way beyond our comprehension. I mean, the universe is way beyond our comprehension. The reason that we no no the reason we think we can comprehend it is a little trick of mathematics called logarithms. Seriously. Uh, so like the logarithm of 10 is 1, logarithm of 100 is 2, logarithm of 1,000 is 3, and 10,000 is 4. So, while you can understand 10, 100, and 1,000, when you start to get up to 10,000, like a million, start to get a little beyond comprehension. And a billion is sort of really beyond your comprehension. But if I said 1, 2, 3, 4, 5, 6, 7, 8, 9, that you can understand. So a billion is really 9.
Oh,
So,
I see.
so
Gotcha.
when you're talking about billions of light years, right? It's really 10 billion, but that's the number there is like 10. A billion light years is like 9. And so when we look at pictures of the universe, they've been reduced by the people who draw the pictures logarithmically.
Mm,
So you are seeing something that looks comprehensible, but isn't. When you try to imagine the distance to the nearest star, and you realize that a light year is 7 trillion miles, you go, I'll stop here, right? You can't understand trillions of miles, right?
yes.
Much less the size of the solar system. In fact, you can barely understand the distance to the moon because you can barely understand the size of the Earth,
Right.
right?
Yeah.
So the circumference of the Earth is 25,000 miles. The distance to the moon is 10 times the circumference of the Earth. So your car, if you're an average person, you may have driven at least 50,000 miles in your lifetime. So you've driven twice around the Earth, but you've never driven the distance to the moon. You really can't understand those things. They're an abnormal, non-human timescales. Can you give me a glass of water? Yeah. Uh, so filaments, nothing you can understand.
But is it kind of like I'm kind of like visualizing kind of like a spider web kind of
Exactly.
okay.
And the thing is, when they simulate the universe, and computers can do that because they don't care about scale. They just throw the numbers in and chug. And when you simulate the universe, you get uh, pictures in the simulation, 3D simulations, that look exactly like the universe itself. It's filaments and voids. But you have to, if you're going to do it, if you're going to simulate a universe, if you're a godlike person and want to do that, you need to add dark matter.
Right.
5 teaspoons of dark matter to every teaspoon of regular matter. Uh, and then you get the universe the way it looks. I want to see if this now we have some people in the audience, and I want to suggest to the people in the audience that you come to the stage, and I'm just going to invite a couple of them before while I'm talking, and then I'll continue. Uh, so, Hesman
Well, I
and
have another
Mike.
question while people are doing
Yes,
that then.
good.
Like with like when we put like satellites up in an orbit, like we like there's a certain level of elevation where it has to be above the Earth, or else gravity will really take hold and bring it back down. Is there
Yeah.
a upper threshold to that where, if it's up too high in elevation, that satellite would get, I guess, slingshotted out of Earth's
N-
orbit?
Not slingshotted, no. Uh, but if you put it up high enough so that the moon has something to say about it, uh, then uh, then it no longer would necessarily follow an elliptical orbit around the Earth. And uh, so the I wouldn't say slingshot, but the further you have the thing from the Earth itself, the more likely the moon can have some gravitational influence and change the
Mm.
orbit from what you'd otherwise be uh, if the moon was not included in the calculations.
Do we know what is the highest elevate altitude? I'm not entirely sure what the word is when you're talking about,
Well, there are these
over.
things called the L1 and L2 points in distance from the Earth. It's about 1 million miles, something like that. The moon is like 1/4 of a million miles. So you put things 1 million miles from the Earth, and uh, the moon is still not res- responsible for most of the gravity. It's still the Earth. It's only when things get close to the moon that the moon has the ability to really change things.
Gotcha.
But I think another thing that's interesting is that if you put things in low Earth orbit, they tend to decay because they run into the upper levels of the Earth's atmosphere, which, while being very diffuse, is still sufficient to knock it down over a period of years, depending on the height. Recently, they're talking about launching a series of satellites that are in really low Earth orbit that would fall out of the sky in less than a year.
Hmm.
And this would be a new class of satellites uh, that whose purpose might be to, do things like talk to your cell phone because it's closer to the surface, you know?
Oh,
Yeah,
wow. Okay, that would be real low
right.
orbit.
Or maybe just to take better pictures of the Earth because it's closer to the surface. So that's a new class of satellites they're discussing. I really don't know their purpose, but I do know that they are definitely considering doing that, or actually in the process of doing it, for that matter.
Like, do we know what is the highest altitude out from low orbit that makes a
Yeah,
satellite worthwhile? But,
yeah,
well,
23,000 miles. At 23,000
oh,
miles,
23,000 miles.
yeah, at
Wow.
23,000 miles, a satellite will take 1 day to go around the Earth. And you know what good that is?
What good that is.
What good would a satellite that takes 1 day to go around the Earth be? What possible value could that be?
I honestly can't imagine much. I mean, this is taking photos really rapidly.
Or perhaps maybe it stays over the same spot on the Earth all the time and never moves from the sky, and so it's always in the same spot of the sky every day.
Oh, that's valuable for sure.
And maybe that's good if you have an antenna on the ground and you want to bounce messages off the satellite, it never moves. So you can use it to transmit television programs. That's what it was originally used for, and uh, uh, and the first one of those was called Telstar. It was used to
I remember
transmit.
that name.
Yeah, it's the first I think uh, geosynchronous satellite, and of course since then, every degree or even half a degree, these things have to be launched at the equator. Otherwise, they bob up and down around the equator, and they don't do the same job they were supposed to do. But if they are launched and they are in an equatorial orbit, then they'll stay over the same spot in the equator and never move. And guess what that means? It means that there's a real estate problem at the equator because that's a thin little line at 23,000 miles at the right directly over the equator. There's like a traffic jam up there. All sorts of satellites are up there vying for space. It's a whole story. I don't know the story, but it's a whole story.
No, you're right. There are international agreements on regulating satellites at the equator, but other than that, it's no man's land.
Right. And you know the first person who, well, he, first person who thought of uh, Earth satellites was a person whose name may be familiar to you if you like science fiction, Arthur C. Clarke.
Sure.
And he was the first person to propose that satellites could be used as communication satellites.
Oh, he gets credit for that.
Yeah, he does. I
Wow.
think he does. Yeah. You know,
Yeah, we
if you
always
are a
take these things
visionary,
for
then you
granted, but
science fiction visionary, you can come up with stuff.
we always take these things for granted. But someone at some point had to think of it first, right?
Right. Even the first rocket, liquid fueled rocket, which was in the United States produced by Robert Goddard, I think. Uh, the New York Times, I think at the time, made fun of it, the idea that it could go outside the Earth's atmosphere. Uh, and the Times reporter who wrote the article uh, said that that makes no sense because outside of the Earth's atmosphere, it wouldn't have anything to push against. Does that seem funny to you?
When we take Newton's
There you go.
gravity, yeah, that seems
No, not
ridiculous.
Newton's gravity. No, 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 no. Newton's second law of motion, which goes something like this. It's biblical in its nature. An object in motion remains in motion in a straight line unless acted upon by an external force. The external force being, of course, uh, the stuff coming out of the engine. And the third law, I think, is for every action, there's an equal and opposite reaction, which is probably the one that
Right.
you were thinking of. Yeah, right. Uh, so let's, Harish, you're great with these questions. Let's see if
Sure.
Abhiram uh, has something to add to this conversation. Abhiram, hi, welcome.
Hello, sir.
And what are you looking at in that picture of yours? You're looking down at the
No, no,
ground.
I was just like randomly
Where,
just take that picture. That's all.
say again?
I just randomly take that picture. That's
Oh,
all.
you randomly, but in this room, okay, I'm looking up and you're
Yeah,
looking down, okay? So can I help
sure.
you look up?
Yeah.
Okay. So, so, uh, so the idea is, do you have a question, perhaps, in astronomy that I might be able to answer for you?
Actually, like I would like to learn things about astronomy, so that's why I'm here. Like, she's my friend Kate, and she invited me in this group.
Great.
So,
Thanks.
like, I need to learn more things about astronomy and
Okay, well, name something. See, I kind of know a lot.
the other universe and things like that, if they
Well, what
exist or not.
what's
I
the
would like
most
to.
amazing thing to you in the universe?
Huh?
What amazes you about the universe? And I'll talk about that.
Like I've heard many things about this universe, and whenever I heard about things like this, I get like so curious to learn, like to get to know and like that.
Okay, let me test your knowledge, okay? Because you're not being specific,
No,
Okay.
I just started to study about this astronomy things for a couple of weeks ago. So
Okay. So,
I'm
so
amateur in here. So,
right, no, no, I'll ask these questions of you, and if you don't know the answer, I'll give you the answer. Okay.
yeah, sure.
Okay. Good. Uh, uh, so we'll start with simple questions. You know, the kind that my that children in school, know. What is the largest planet?
The largest planet, I guess, Jupiter.
And uh, and what? Let's ask this question. How many moons do you think Jupiter has?
Mm, I'm sorry, I don't know.
Okay, it has
Can you say
four.
that?
It has four big ones and about 80 little ones. Okay,
Oh,
uh,
okay.
uh, if I name the planets and I say Mercury and Venus and Earth and Mars and Jupiter, what did I skip?
Pluto. I mean, no, not Pluto.
The asteroid
Mercury,
belt.
Venus, Saturn.
No, I
Yeah,
skipped the asteroid belt. Okay,
asteroid.
so it's after Earth and Mars is the asteroid belt containing lots of little planets, dwarf planets that are much much smaller than Mars itself. So they don't actually not a planet, but they are pieces of a planet that never formed. So so that's next. Okay, then
Yeah,
after Jupiter, you have Saturn. What's after Saturn? Do you know?
Uranus.
Uranus. Okay, and Neptune. Okay,
Yeah,
after Neptune, are there any more planets?
like Pluto was a planet, right?
Pluto's not a planet anymore. Okay. Okay.
Yeah, it's
Are there?
not a planet. Oh, yeah.
All right. So how many things out there are like they're like Pluto? Pluto's not a planet; it's a dwarf planet. How many dwarf planets are there?
Oh, I don't know, sorry. I don't know. Sorry.
Something like 20 big ones and millions of little ones.
Oh, okay.
If you count, if you decide that a planet is like maybe, say 1 kilometer in diameter, then you
Mhm.
get millions. In fact, trillions. Uh, so there's lots of them out there, but in terms of big ones that you can see with a telescope, there's about 20.
Okay. Okay.
Okay. All right. Now, uh, uh, how big is the solar system?
Um, I'm not pretty sure. Like,
Okay. So I'll give you an answer like one light day. In other words, the solar
okay.
system it's sort of the edge, is about one light day. What's the distance to the nearest star? Okay, so the answer to that is 4 light years. Okay, all right, now, what is the name of the galaxy that we live in? Okay, so the name of the galaxy we live in is the Milky Way. Okay, you with me so far?
Hello.
Yeah,
Hello.
are you with me so far?
Yeah, yeah. Like, my mom just called me, so that's why I'm sorry.
Okay, what was the last
What did
question
you
you
ask?
heard?
What did you ask?
What was the last question you heard?
Like, which galaxy or something?
Yeah, what's the name of our galaxy?
Milky Way.
Good. Uh, and how big is it?
Uh, as you said, like, one day of light year or something like that.
So our Milky Way galaxy is 100,000 light years. 100,000 light years.
100,000. Oh, okay, okay.
Light years. Okay? What's the
Yeah.
distance to the nearest big galaxy, like the Milky Way?
Nearest galaxy. I don't know, sir.
Do you know the name of the nearest big galaxy?
No.
Okay. It's Andromeda, and it's about 2 million light years away.
Oh, okay. So
Okay.
like I get to know about this right now, and I'm still learning. I'm trying to.
Right. So I'm teaching you.
Yeah.
Okay. Uh, okay. So how many stars do you think there are in the Milky Way galaxy?
Um. Does that comes in a like a count?
Yeah. How many stars in our galaxy?
I don't know.
Guess.
1,000 million, something like that.
One
Probably.
thousand million is a good guess, but it's 400,000 million.
Oh,
Okay.
okay.
In other words, 400 billion.
400 billion or
Yes.
million
In our
or
galaxy.
billion.
Okay. Good. Now, is the how many galaxies do you think that we can see with our telescopes?
With
Galaxies like the
our,
Milky Way.
I guess there's only one.
What?
There's only one. I guess
There's what?
we can see through the telescope. There's only one galaxy that I guess it's Milky Way.
No, but how many galaxies like the Milky Way and Andromeda are there in the universe that we can see, that we count?
Um, um, I don't know, sir.
So something like a couple of trillion
Trillion.
galaxies,
Oh,
e- each of which have something like 400 billion stars.
uh-huh.
Okay?
Yeah.
How old is the Earth?
Huh?
How old is the Earth?
How old?
Yeah.
Pardon me, I didn't get that.
How old is the planet Earth?
Um, how old this
Hmm.
Earth?
Hmm. Yeah. How old?
Let me guess, like
Yes.
500. Uh, no, no, not 500. Or about like that.
How old? How old?
Couple of years.
How many years old is the Earth?
500 years or something. Like no, no. Um, maybe maybe 10,000 or something like that.
10,000 years, right?
Yeah, yeah.
Okay. Uh, it's not 10,000. It's not a million. It's not a billion. It's 4.5 billion years, the age of the
Four
Earth.
and a half million.
Half
Oh,
billion years. Same age as the sun.
oh,
Okay?
yeah.
Now, what is the universe?
Hmm?
How old is the universe that we live in?
About that. Um, when it
It's
comes
older
to
than that.
Earth, it's up to like 4.5 billion. So
No,
when
no,
it
the
comes to
Earth is four
universe,
and a
I
half.
guess,
Earth is 4.5
yeah,
billion. That's 1,000 million.
billion.
Uh, four,
So
four,
I guess this universe
4,500
is like
million years old.
I guess this universe is like 6.5 billion or something.
So that's a good guess. The age of the universe is 13, almost 14 billion years old. That's a good number.
Oh,
We know that number very accurately. We know the age of the universe. We
oh, okay.
know the age of the universe. We know the age of the earth. Isn't that amazing?
Yeah, it's so amazing. Yeah,
Right.
I can see that.
And there's no doubt about those numbers.
Of course.
So those are so that's so when you say you don't know anything, you want to know about astronomy, I've just sort of taken you on a short tour of the universe.
Okay.
Okay? So there's a lot to learn, and any astronomy book that you pick up will tell you all those things and more.
Um. Right now, can you like suggest me some of the books of
No, I
astronomy
don't have a
that I
book to
can?
suggest to you. I
Okay.
suggest you go to a store, say, "Can I see a astronomy book?" You pick a book that has nice, pretty pictures.
Oh, okay.
And you pick a book with pretty pictures and lots of words, but not too many words because you don't want to read too many words. You want to look at the pictures and you want to
Uh,
read the captions, and after you've seen the pictures and you have a context for what you're seeing. See, some pictures are small, only like 1,000 light years in diameter. Some pictures are very large, millions of light years in diameter, or billions of light years in diameter. They're all very different pictures. They're all very pretty, but you need to
oh,
know what's what. So maybe a book that starts at the beginning where we are in the solar system, goes to the stars, the galaxies, and out onto the rest of the universe might be a good book that you can find. You know, look at
Yeah,
the pretty
sure,
pictures.
sure.
Yeah, right. Kate Joseph, did that help you any? Yes, good, good. I'm glad. Uh, and Abraham, Abe, Hiram, I hope you come back. Obviously, you've not been here before, but I hope you come back to Small Steps and Giant Leaps. I'm here every other week. Every other week, I'm at Astronomy and Astrophysics, which is another house, and I do this room at 11 o'clock Eastern Time in New York City uh, every week on Tuesdays at 11 o'clock, and I go on till 1 o'clock. I do it for about 2 hours, and you're welcome to come and ask questions instead of me asking you questions, right? Which is what I was doing tonight to find out what you knew. But but now that I know what you know, anything you ask,
Sir,
I can just give you an answer based upon what you know.
sir, I
Yes.
have another question. Does time travel possible?
No, it's not.
Okay, there are
sorry.
Sorry.
five paradoxes in the bootstrap paradox, grandfather paradox, Hitless paradox. There are five.
Yeah,
So,
there's paradoxes which make time travel impossible. Yes,
okay, sir.
that's true. Right. It's one of those things that seems if you want to travel in time, then you have to imagine it's science fiction, but not science.
Okay, sir.
Okay. Hamdi, uh, uh, welcome to this stage. Do you have a question for me?
Hello.
Hello.
Okay, to be honest, I was never interested in, you know, the universe and that and astronomy or, you know, this is all new for me, to be honest.
Okay,
But you
that's
know,
good. It was new for Abraham as well.
yeah, but I have a question actually.
Okay.
What are the metrics to decide this galaxy is like 13 billion years?
It's interesting. There's an easy metric that is one of the ways we do it. Okay,
Okay.
and it's really understandable. Okay, do you have any background in mathematics at all?
Mm,
No. Okay, fine. I won't
yeah.
do math. Uh, uh, okay, so if you if you go out there, and it is possible for astronomers to determine how fast an object is moving away from us. And the reason we can tell that is because when something is moving away from us, the color of it changes. And
Okay.
just like the sound of a train moving away from us goes from a high pitch when it's coming towards us to a low pitch when it's going away from us, the wavelength of light, when something is moving away from us, turns from blue to red. We call that
Okay.
redshifted. Uh, and and the galaxies, not stars, because stars are too close. Galaxies are further, and we're talking about not the nearby galaxies even, but the faraway galaxies that are still relatively nearby. And I'll tell you what relatively nearby means. It means 50 million light years. That's relatively nearby. Why would I say such a terrible thing? because the universe is is billions of light years.
Yeah, yeah, exactly.
So I'm talking millions, so that's nearby. Okay. So,
Yes.
you ignore things like Andromeda, which is a nearby galaxy, very nearby. You don't count it because it's 2 million, and I'm talking about 50 million light years away. So if you start counting those galaxies, you notice that the further a galaxy is away from us, the faster it's going away from us. And while that is quite amazing, it turns out to be it's amazing, but it amazed people 100 years ago. It's no longer amazing. It's maybe amazing to you because you may have just heard about it,
Yeah.
but people just heard about it for the first time about 100 years ago, a little bit less than 100 years ago, and around 1930, and when they realized the universe was expanding, okay, that's interesting. But the thing is, the further something is away from you, the faster it's going away from you. That's pretty wicked. Okay, so
Yeah.
so so think about it. If something is the further you go away, the faster it's moving. Now imagine that instead of a universe, you have a loaf of raisin bread, and the raisin bread is in the oven and it's cooking and it's expanding. The nearby raisins are moving away from each other at a certain speed, but the raisins that are furthest away in the raisin bread are moving away faster. So the further you are away from a given raisin in the raisin bread, and by the way, in this analogy, you are the raisin I'm talking about, okay? We are all
Okay.
the raisin I'm talking about. All the other raisins, meaning galaxies, are moving away from us. The further they are, the faster they move away. Well, look, if I could do that, then you can figure out how long ago all the raisins were together. You can figure out how long ago all those raisins were in the same place. And when you do that, you come up with the age of the universe. That's how they do it. That's one of the many ways they do it. But that's the most easily understood by uh, someone who doesn't have math or physics.
That's fascinating. That was a
Yeah.
great
Yeah. I
metaphor.
mean, I mean, it couldn't be better, you know.
Well, the raisin analogy is not mine. Okay, believe me, it's not mine. What is mine in this respect is that I'm giving you the visualization of not the expanding universe, but he asks the question, how do we know how old the universe is? And for that, I reversed the thing. And instead of having the loaf of raisin bread expand, I imagined what it was like when all the raisins were first together. And that's how I answered his question. So I mean, it's not really my analogy. It's just I expanded on it a little bit. You can look up raisin bread using universe, and you'll find thousands of people always use raisin bread. I don't know why it's raisin bread. It's always raisin bread.
You
There's
know,
poppy seeds too, you know.
Could be poppy seeds, but there's too many of them. We need to be able to locate an individual raisin, and they're the right shape. They're a little flat, like discs, and
True, true.
Milky Way is
Yeah.
sort of flat, like a disc. So raisins are better.
when I was a kid, actually, I was so much into science. But here's the thing: since the English wasn't, or it's still my second language, and I wasn't taught in the science in English, that was listening to some stuff like that about the universe. It seemed to be very complicated, because I'm not well aware of the language, the English language,
What's your
because it's
first
not,
language?
it's Arabic.
Ah, and what country are you from?
I'm from Egypt, actually.
Uh-huh. Ah, yes. And and also, well, when I was in Egypt, uh, one of the
Okay.
things that I learned, I've been in Egypt a few times, and the Egyptian guide that we had with a few weeks for us, one of the things he told me is that he had been to college but he had never studied science in college. Uh,
Not in college.
right,
Yes, he's right.
right. So you have been, the Egyptian system tends to leave out important facts like evolution and astronomy.
Yeah, that's a fact.
Yeah.
And even when we taught the science, that was that was the basics. Like the name of the planets and the solar system. The basic stuff, and it all was in Arabic. That's why whenever I come across a room like this, I just go and try to, to pretend that like I understand everything. But you know, like
No, but really,
honestly,
A lot of people in this room do, my friends, so don't worry about
no,
it.
my purpose in this room is to help people like yourself learn something about the universe. So you can ask me anything like you did, and those are the best questions because I can help you with those answers.
yeah,
So if you
this
have,
one was amazing.
yeah,
Yeah.
I mean, for example, here's something that I learned today. Not, yeah, today, and although I think it's very interesting, and not a question that you would have asked, okay? But so the question, let me give you a question, then I'll answer it, okay?
Okay.
So, Dr. Laird, what do you think is the probability of life on other planets? Okay, a lot of people ask me that question a lot, and of course, nobody knows the answer to that, and neither do I. But I found out something that I think is very interesting. Uh, Hamdi, do you know what amino acids are?
Sorry, I couldn't catch it actually. Would you repeat that
Do you
again?
know what the term chemist? I'm talking chemistry here, and I'm saying, do you know what amino acids are?
No.
Okay. Do you
No
know?
way I could.
No. I'll answer that in a second. Do you
Okay.
know? Do you know about DNA?
Yes.
Okay. Do you know that DNA is made up of four nucleotides whose letters are A, T, C, and H? Do you know that DNA is all about those four little letters, and they explain everything? Did you know that?
I know about the four, like, not, yeah, I don't know how to
G
say
and
it.
A and T uh, and C. Uh, those are things that are called nucleotides,
Okay.
and DNA is simply made up of four of them. That's the whole thing. Four nucleotides, and you can look it up. You can look yourself up in a dictionary once you get tested, and the dictionary that will come out will be just those four letters repeated in different fashions up and down your DNA, and that's who you are. Just those four little letters. It turns out that they found those four little letters in outer space. All four of them are found outside of the Earth. In other words, the Earth put together those four things to make you, but it's out there in outer space ready to be put together by on another planet someplace else in the universe. So basically, any place in the universe that has the ability to make a rocky planet like ours is a place that would have those four building blocks on day one. Now, nobody knows how the Earth put it together to make us, of course. But the interesting thing is that every planet starts out with those Lego bricks. That's what I learned today, that every planet starts out with those Lego bricks. Isn't that cool? Now, I still don't know what the chances are of life because nobody knows that. Because nobody knows how easily those Lego bricks can be formed together to make us. But it's an interesting fact to know that the universe is filled with the Lego blocks that make build us. I think that's tremendously fascinating.
That's a good metaphor as well.
That's not a metaphor. Oh, Lego blocks, I guess, is a
Yeah,
metaphor.
Yeah.
the leg blocks. Yeah, that's what I'm talking about.
Yeah, yeah, yeah. But the thing is, nobody has any idea how the pieces fit together to make. Because what you have to do, if you're doing that, you have to build something uh, that can reproduce itself and and uh, and eat things, so it can grow and make other things like itself. In other words, you have to reproduce, and those things don't reproduce. And if you squeeze them together, they still don't reproduce. So you have to figure a way to to get uh, those building blocks to to come together.
There's an idea though, doctor.
Yes,
They say we might be microorganism from other planets hidden an asteroid or something. That might be a possibility, right?
yes, that's called panspermia. And it is a definite possibility. I wrote my PhD thesis partially on that, and in my thesis I discussed it as being spores sent into stellar space. But these days it's thought that it's not spores, but actually meteorites, because as we know now, there has been two interstellar visitors that we have seen come to our solar system, that we have actually seen come in. So there's no reason, there's every reason to expect that our solar system is being constantly been bombarded by pieces from other planets in the universe. There's every reason to suspect that. So the only question is not whether there are pieces from other planets in the universe coming our way. The answer is yes. The only question is, do they contain life? And was the source of life on our planet? And the reason I think that it's interesting, but it's not that interesting, because if it is, if life came here from elsewhere, then you still have to explain how it got there in the first place. And you're stuck with the same question on another planet. So it doesn't really help matters very much.
That's the magic, huh?
Yeah. But what it does is it says, look, if life is rare, and if it's exceedingly rare, then maybe one place in the universe made life and then it seeded the entire universe. That's a cool idea. But another equally cool idea, and pretty much the opposite, is life is not rare, it's the rule rather than the exception, and then life begins everywhere anytime it can. So it depends entirely on what the probability that you assign to a process who we know nothing about. So you're free to assign a probability, and if it's low, then panspermia is more probable, and if its probability of life is high, then panspermia is unnecessary. So that's that's what I said in my thesis when I wrote it, and that was approved of by Carl Sagan, actually. The thing that I regret is I never published it. Now what I wrote is meaningless. So because that was in 1972, 1972. So anyway, Saeed, uh, uh, that's cool. I see you haven't been here before. That's interesting. Or have you?
I think I was. I like the name. Uh it's when the first man walked in the moon, Armstrong, right? Small steps, giant leaps.
Yeah.
I like the
Right.
name. It's cool.
Yeah. No, no. I like the name of this room. This room, and that's why I'm here. I have a degree in astronomy, right? But I have no degree in space science, if you will. When I went to school, uh, I had a choice of becoming an astronomer or a rocket scientist, and uh, and I chose the nearest school to me, and I became an astronomer. But if I'd chosen the furthest school for me, I would have become a rocket scientist, and then I would be an expert in this room rather than just a hanger-on. I know a lot about rockets and rocketry and all that sort of stuff and what we're doing in the space race, but only as a curious individual. Uh, I'm not qualified by any,
Oh,
degree.
you're qualified enough, doctor. Thank you for your stuff. It's really
All right,
cool, especially if you're a science nerd. I just have another question, doctor.
please, no, no,
Have
go.
you ever heard about this leaks about like UFOs and stuff? Like, what's your thought about them? If there's like alien life and if they're visiting us, well,
Well,
that's changed the whole thing, right? We might be even engineered or something.
uh,
What's your thought on that?
I like what uh, Neil deGrasse Tyson. I saw him answer sort of a question about this recently, and uh, and I thought his answer was really good. He said uh, he's speaking to all those people who think they have been abducted by alien spacecraft or meet an alien spacecraft, and they said, look, next time you're inside an alien spacecraft and they're operating on you, just grab a handful of whatever's on the table next to you, okay, and bring it back, all right, and give it to us, and then we'll have some evidence. The problem is we don't have any evidence. We have no artifacts. We have no evidence whatsoever. We have anecdotes, but anecdotes do not constitute evidence, and leaked stories do not constitute evidence. Evidence is something that independent scientists can examine. If there's a story that people tell, and there's data that people present, that data has to be able to be verified. There's no verifiable data that can be used to support the idea that UFOs, or as they're now called, unidentified aerial phenomena, are real. We just don't know it. It's outside of science. It falls in the realm of anecdotal stories, and they are certainly unexplained. There's plenty of them that are unexplained, and the people who have explained them and have observed them are really, honest people. The problem is that they're not trained observers. Nobody, unless you're trained to do this, is a trained observer. I'm not. You're not. Uh, if I saw an unidentified aerial phenomenon, I would qualify as an untrained observer, and so would you. So most people, even airline pilots or fighter
These
pilots
were
who were
like
flying,
marine pilots, right? Like two of them, and they
yes, yes, they are,
testified against Congress, I think, in US,
but
right?
they're not
I remember the
trained.
whole thing. This is different, doctor. Like when you say someone normal, yes, but two aircraft saw it clearly, like the orbits and orbs and stuff. They testify against Congress.
No, no, I believe it. But the problem is it's testimony. Okay, it's not evidence. It's not. If you can't hand it to me so I can examine it. And that's why in a court of law, what they do is they present the physical evidence in the courtroom.
Okay, okay, never mind, doctor. Let's go another lane. Like,
Yes.
do you think it might be real? I'm not saying they're saying truth. I'm
Okay.
pretty sure they're not.
That's
Like,
fair.
yeah,
That's fair.
yeah. It might be. You think alien visited Earth before? Because if you traveled when you were younger, if you went to Egypt,
Yes.
I'm pretty sure you saw some stuff.
Yes, of
I'm not
course.
talking about History Channel, right? I think they visited us before. We had like four major catastrophes, right? It's kind of be like engineering. It's my idea might be wrong. I'm
Yeah,
asking your idea
the
on it.
reason I think that it's wrong is because human beings tend to underestimate human beings. It was recently discovered that half a million years ago, when human beings were not, in fact, human beings yet, human beings were building buildings. They weren't human, but they built buildings. Now you could say aliens helped them, but they found evidence of human beings, or not, not Homo sapien, but Homo
Hominids.
erectus.
Yeah.
So the thing is, we always underestimate what can be done, uh, and so I will reject any theories that say that we needed the help of aliens to build whatever structures you see. The pyramids did not require aliens to help them out. They did it all by themselves.
I wasn't talking about the pyramids,
What are you
sir.
talking
Half of
about?
the world believed that the aliens, was involved
No,
in
no, that
building
was
pyramids.
millions and millions of like slavery work. I know about that. I'm
Yes.
talking about their ancient encryption. They had very like too many drawings of a spaceship.
Oh no,
I,
I've seen those pictures. I have myself seen them while I was in Egypt, and so. Uh, but the fact that they look like they're aliens doesn't mean they're aliens. It's just that's it.
I've saw the same thing though. I've seen the same stuff almost in
Yeah.
our ancient other some other ancient part of the world. They all can't be wrong.
Yes, they can. Yes, they can be wrong. They can all be wrong. There's the theory was first put forth by Eric Danigan and his series of books called Charity of the Gods. And maybe not the first time that this theory was put forward. And he wrote a series of books, maybe 30 years ago, Charity of the Gods. But you can find another book that is in response to that, and it's called Crash Go the Chariots, and you can find that someplace. And they will answer these questions that you are posing to me, okay? And they answer the question to my satisfaction, and hopefully to yours, if you would be willing to look at those, find those books. You can always find theories that propose to, it goes like this. There is something that is interesting phenomenon. Scientists can't explain it, so the answer must be aliens. That is the normal, so the normal argument goes like that. It doesn't have to go like that. It can just be we
Well
don't,
done, Laird. Well done.
Uh,
it just can be we can't explain it, period. That's it. And leave it at that. But it doesn't have to be aliens, you know.
no,
It could be.
that's the whole idea of there are more intelligent life other places that visited Earth. That's the idea.
Okay,
That's
so
what
now
I'm
the
asking.
question. So now the question is, uh, there is this. The question you're asking is was posed famously by Enrico Fermi, who asked the question, "Where are they?" Okay,
Hmm.
that was the question he asked. Okay, and it's now known as the Fermi paradox. You can look it up. Fermi paradox, and it's not a paradox really, but that's what they call it. And you can look it up and Google it, and you can find 50 answers to the question, where are the aliens? And some of the answers are, well, they were here and they went away. And some of them answers are, well, they're up there, but they didn't come down. And some of the answers are, well, they did come down. They buzzed a couple of high school students in Arkansas and then left. So you can find all those answers up there. There are lots of questions and lots of answers to the question. So the question, and also the answers also are, well, they never were here. They can't get here. Or another answer is they tried, but they failed because the distances are so large. Or another answer is they never even left their own planets because every time they tried to leave their own planet, they wiped themselves out just like we're likely to do next week. You
Hmm.
know, so there's a lot of answers to the question of why they aren't here, and whether they could have come here. And so, uh, uh, so my own personal favorite of all of those 50 answers is that space is too big. And when and if you imagine intelligent design and the universe was designed by a creator, then I think it's awfully funny that the creator arranged stars to be so far away from one another that it would take more than a lifetime to get between the stars by any gauge of a lifetime for a carbon-based life form. So I think it's really funny that the universe is designed so that we can't visit each other. That's my opinion. Now, you may think that the universe is designed so that we can visit each other, and that's your opinion. And then you think, well, maybe there's aliens, and then
Oh,
maybe there are.
I definitely believe we live in a simulation, like no doubt.
Okay, no, that's fine.
Uh,
It's fine. I can't prove that aliens haven't been here. Okay, and you on the other hand can't prove that they have. So we differ in our point of view. But I would say that most people who are of my ilk, people who have studied physics and astronomy and all that stuff, feel that the difficulty of getting here from there is such that it's unlikely that they have done such a thing. But it's not impossible because, in fact, there's millions of dollars being spent to see whether we can find such life forms out there in the universe, life forms that have the ability to travel between stars. So if you hypothesize that in fact it's possible to travel between stars as an intelligent life form, then you can also hypothesize that if you don't wipe yourself out and you live and your civilization survives for millions, not tens of hundreds of years, but millions of years, that you'll have nothing better to do than to redesign a galaxy. And if you are looking for redesigned galaxies, there are people spending millions of dollars looking for redesigned galaxies. So the idea that space travel is impossible is what I'm saying, but it isn't necessarily any more true than just my opinion.
But for now, plus they don't have to travel; they can just teleport. The wormholes are
No,
possible,
no, no,
right?
no,
You've
no, no,
seen
no,
the
no,
black
no, no,
hole.
no, 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 no. Teleportation is one of those little things, and wormholes are one of those little things that falls outside the realm of science and falls into the realm
How about
of
two black holes?
black holes are real, white holes are not.
Okay, if two black holes connect to each other, what happens?
You get a prize. In other words, if you find two black holes that connect
No,
with
if
one
it's
another,
not possible, then
no, no,
why
I
do
didn't
you
say it
believe?
wasn't possible. I didn't say it wasn't possible. I just said that you get a prize for finding the first one.
Well,
Because there isn't any yet.
well,
But
there's no
doctor,
wormholes, but there is black holes. We saw the black hole, right?
yes, they're all over
Just
the
never
place,
mind, doctor.
everywhere you look.
How long
What?
you think we're gonna take to colonize the moon? Like they should do something, right?
I'm first of all, you have to know if you haven't been around me long enough. Yeah, I'm quite a bit of a skeptic, so that you should be getting that by now. Okay,
I
okay.
know. I
If you
got it.
haven't gotten it, you should get it. Okay, so
It's okay.
don't go with I'm not the authority here in this room about such things. I'm just giving you my opinion about that. But so you asked my opinion about colonizing the moon.
Yes, sir.
Okay, so I'll tell you what. Here's a little fact that you might find interesting. They haven't built a spacesuit that works on the moon yet. You know why? Because moon dust is made up of jagged little pieces of glass that cut through any material. And if you want to live on the moon, you better have a spacesuit that can withstand those little jagged pieces of glass. And they haven't built one yet. That's and so one day they may, and so in that case I'll say, God bless them, you can go colonize the moon. But until you figure out how to build a moon suit, it's going to be a upward slog. So do you think that they'll be colonizing the moon anytime soon? It looks like a great place to go, especially on vacation, right? Can you imagine a basketball game on the moon? There's a lot of reasons why you want to go, right?
Okay.
Ballet on the moon. There's so many reasons why you want to go to the moon. And I think that people will eventually go there. But I don't believe we will colonize it. I believe it will become a vacation destination rather than a place that people live and raise children. For example, can you imagine raising a child on the moon? I mean, what mother would like to give birth to a child on the moon and raise them in 1/6 gravity? Are you kidding? I'm sorry. I don't see that coming anytime soon. And the moon's gravity isn't going to change anytime soon.
Must
And
be aliens.
who's to say that you can actually give birth to a child that can survive in 1/6 gravity, right? How do you know, right? So there's lots of reasons why I'm a little bit skeptic about colonizing the moon. Going there, having a good time, building hotels, all that's fine. Just not living there.
Mars then.
Mars, I believe, is equally unlikely. And the reason, I'll give you one reason, okay? You go to the Museum of Natural History, for example, in New York City, and you go to the new room that they have, and there's a room showing all sorts of insects, and they tell you things like there's a trillion insects for every human being on Earth. Okay. Now I ask you this question: how many insects are we going to bring to Mars to make it, hospitable for us? Because we need insects on this planet. Okay. Are we going to bring insects to Mars? And if we do, what are they going to live on besides our excrement? So we're going to build an entire ecology that's going to survive without any of the stuff that we, in fact, grew up with for 4.5 billion years on this planet. You're telling me we can build a survivable colony on Mars without any of the stuff that we need to survive, like fungus, bacteria, all the birds and the bees and the rats? And we need all that stuff you know. So I don't think we're going to colonize Mars. I think we're going to try, but but to be able to raise generations of people on Mars. Remember, Mars is a 1/4 gravity, and it's it's got it's got meteorites coming down from the heavens just like the moon does. It's got ultraviolet coming down from the heavens just like a moon does. It's basically the moon, but a quarter of but instead of uh, uh, 1.5 light seconds away, it's 20 light minutes away. And you're going to keep sending people there? For what purpose? To keep us from knocking ourselves out as a species? I think the thing you want to do if you want to save us as a species is put things in low Earth orbit and keep it supplied from the moon. That makes sense to me. But this is all my opinion, right? Absolutely nothing here could stand this test of an argument of somebody else in this room, okay? So don't take it as anything more than just me mouthing off, okay? So, right. So who's next? Oh, Jack. Jack.
It's nice to be here,
Yeah,
directly underneath you
I know that. Jack is normally in Lisbon, but he's right now a floor
in your
below me
basement.
in my basement. Right, right. And that's my grandson there, and that's Jack.
Okay.
And
Good
oh, and,
good
and
evening, everybody, or
Hi, Jack.
good morning if you're braving the 6 a.m. or 5 a.m. Time that this program starts.
It's
you know,
7 a.m. here.
Guten Morgen, Hania. Hania showed up. Wow.
oh, really? Wow.
Yeah. Consider yourself a superstar, Dr. Laird.
Yes.
That's an early morning in Germany right now.
Welcome, Hania. I don't. Oh, there you are. Welcome. Hi.
So we're in a new year, and everyone is, having these listicles about different things you should do in 2024. And
Listicles. I like
I'm
the word. I like the word listicles.
oh yeah, I invented it about 25 years ago.
Okay.
Uh, and I'm wondering what are the things that you're looking forward to doing or seeing, I suppose, when it comes to the stars out there. What's happening this year that we should be on the lookout for?
Oh, that's a good question. There was an article that said just the answer to your question that I didn't read, uh, uh, and it was specifically designed to answer the question not about astronomy, but about what's going to happen in terms of rocketry. Uh, and I did not read what we're expecting in 2024 in terms of rocketry. Uh, there's a lot of you know things that Elon Musk might achieve, and in this room, the I guess the question uh, highest on people's minds, given that it's small steps and giant leaps, is what might Elon Musk and the rest of the rocket community do in this year? So I'm certainly hoping that Elon Musk gets his stuff together and produces a rocket ship that proves his he's essentially telling us that it's possible for
I know Laird has a history of falling asleep on this thing, but this is ridiculous. Laird, you okay? Should I run upstairs and administer CPR?
No, he's on mute.
I'm in a unique position right now where I can actually walk upstairs and see what the hell's going on.
oh, I lost the room for a second. I came back in, and so what happened was,
You okay?
yeah, no, I'm okay.
All
What
right.
happened is I lost the room, so Haris became a moderator,
Oh,
and then
no.
Oh,
when I
now
came
we're all
back in,
screwed.
Yeah, seriously.
my mic was muted. But all I did was my finger. I lay it to my fingers because I'm 78, soon 79 years old. My fingers don't have enough moisture in my fingers, and so I don't produce a capacitance between my finger and the screen. So when I touch the screen, nothing happens. So I lose the ability to move the screen around, and then suddenly I randomly touch something, and I'm lost in space, if you will. And I lost the room when I came back. That's what happened. Anyway, so welcome Haris as moderator.
I shall not abuse the
I
power.
always knew he was your favorite.
Right. Well, he comes a lot. He comes a lot. Okay. So let's see. So Elon Musk. One of the things that I've been finding out, he has a couple of things that he has to prove to me. And forget the rest of the world. To me, he has to prove to me again because I'm a skeptic. Uh, I am skeptical that his second stage rocket is going to be able to re-enter the Earth's atmosphere and land uh, undamaged without losing its uh, 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 heat tiles. Uh, and so of that I'm skeptical, and I would love to find out just how wrong I am. And FYI, everyone in the room, you should know that I am a skeptic, but I also am always wrong. 90% of the time, my skepticism turns out to be wrong. So you should not take me. So that's all I'm saying is I'd like to see him succeed, I'm worried he might not. Uh, and it's necessary for if he does succeed, and he produces a reusable rocket, then all bets are off. What I mean by that is everybody who's been designing spacecraft since the get-go has been designing spacecraft whose diameter is constrained by the diameter of the fairing that can be placed on the satellite that's being launched. His the fairing that can be placed on the satellite that he is launching would be 10 times wider. And so you could have built the James Webb telescope for a tenth the price if you launched it with with his spacecraft. And if you're going to visit the outer planets and check out if there's life elsewhere, you want to be able to send a laboratory that's 10 times heavier than we've ever been able to launch, that might be able to answer questions we never even thought to ask because we couldn't possibly build a machine that could answer those questions with the weight constraints that we have. So as soon as Elon Musk's spacecraft has the ability to do what it's cracked up to do, everybody will be redesigning their questions to answer what he can in fact deliver as a launch vehicle. So I'd be really interested to see what happens. So that's also something else I'm looking forward to this year. I'm looking forward to spacecraft wise. Uh, there's
Should I go outside at 3:30 in the morning Eastern Standard Time to look at meteors, or is it not worth it?
oh is that tonight?
At 4 a.m., yeah.
Oh, you can look now. I'm pretty sure it probably peaks at 4 a.m. And yeah, and Jack, take the car, uh, and position it at the Warner House. Okay, put it in his driveway. Lean the seat back. Look up at the sky and see if you can see it, because that's what
Well,
I did.
I can just go outside here and I guess
No,
the cloud coverage is pretty
no. The,
thick.
the point is that I went to the Gemini's media shower. I stood out. I sat in my warm car for 45 minutes and saw 12 meteors. So it's not like it's going to come crowning down on your head. If you lay in an open field, you'll see many more. But if you just look up, you'll only see a small portion of the sky. So
Well, given that I'm on my seventh PBR of the night, maybe it's a bad idea.
yeah, maybe it's a real bad idea, right?
I mean, it takes about five just to get through this clubhouse, but
Yeah, thanks.
Love the support. Love the support.
All right, so I'm looking forward to that. I'm looking forward to a rocket that has been uh, uh, 3D printed, making it into orbit. That's possible this year, and it would be real competition for Elon Musk because the difference with 3D printing rockets is if you don't like what you built yesterday, you can press a button, change the instructions, and build a new one tomorrow, and you don't have to re-engineer anything. You just press a button and start over, and a month later you've got a new rocket with a new design. So that's looking forward to that. Uh, and I'm looking forward to the build. I'm actually coming up with a spacesuit that works. I'm looking forward to them coming up with a way to land on the moon because Jeff Bezos seems to have an idea how to do it his way. I'd like to see how that is coming down the pike. I'd like to see him build a rocket that doesn't just take passengers a few a few tens of kilometers into the sky and then lends them back. The trick is not to get it up high. The trick is to get it traveling around at 18,000 miles per hour. That's the trick. He hasn't performed that trick yet, anything. So I'd like to see him come up with something better than the parlor trick he's doing with new Shepard. And what else? There's uh, there's a spacecraft on the way to Jupiter. I think that has got a special mechanism on board. It's going to try to communicate with the Earth via lasers, not radio. It's going to send
Oh
a
yeah,
laser beam.
that's really cool. Yeah.
There's all sorts of things. And then in astronomy, they're going to try to figure out uh, how those galaxies that seem to be too big too early got to be too big too early. Maybe they're not that big, and maybe there's no problem. But there's a lot of answers that we're going to come up with the James Webb this year that's going to be new and exciting.
Okay, I
So,
got a stupid question.
ah, go.
So with space expanding, right? I can only imagine that that means that space everywhere should be expanding by the
But you can't hear.
same rate.
Okay.
Is that
Sorry,
fair to
sorry. I'm sorry. I
Okay.
wasn't listening. Jack just walked into the room, and I just told him he can't hear what you guys are saying because I have my earphones on, and so he can't hear. But Jack, I could take my earphones out, and then you could hear. Okay, I'll do that and see how bad that thing is. Okay, Jack, so you can hear. Okay. If you guys don't like how I sound now, I'll put the earphones back in. But here we go. Go ahead. Sorry.
All right. So is it fair to I just got to ask this like question first. Is it fair to say that no space expands, I can understand how that works, but or not really, but space expanding. So is it expanding everywhere by the same rate?
Good question. Uh, there is a spacecraft that has been charged with answering that question, so we'll have to wait the answer. Uh, there's a spacecraft called, you're talking about the geometry of space and whether the geometry of space is the same everywhere. So if you were going to name a spacecraft that was studying the geometry of space, what would you name it?
Um,
Geos.
You would, Euclid. You would name the spacecraft Euclid.
oh yeah, yeah, yeah,
Oh.
yeah. That gets you. So I guess the actual question is like, if space is expanding, like
Not if, it
how?
is. It is.
Okay, well, how is it that matter can exist? Because like
Uh,
over time, if space is expanding ever, would not also include the space in between subatomic particles?
no, uh, uh, the that's a good question, but uh, the it's a good question. Okay, I'm not gonna. I don't think I'm gonna answer it in a way that satisfies me, much less you. Uh, but uh, we're talking about uh, uh, you're talking about like a light year of space, right? And a light year of space expands by a teeny little bit, and that's pretty much enough to do that. But inside of an atom, there's not a light year of space, so you could say proportionately, and I would argue, no, you got me there. But but the I think that the it's all about the immensity of space that's expanding rather than the smallness of space. When they talk about the space expanding, so that everything disappears beyond the horizon, they're not talking about atoms starting to fall apart either. You know, and it has, like, I think, to do with gravity. Okay, maybe that's the answer. Gravity is the weakest force in the universe. Do you know that? Okay. So if gravity is the weakest force in the universe, it has very little ability to influence what happens next. So if dark energy says, I got you there, gravity, I can trump you and I can expand beyond what you think you should be able to control. In other words, given gravity should slow things down and not speed things up. So dark energy's gone. I'm better than you, gravity. But nevertheless, electromagnetism and the strong force and the weak force got gravity beat by a factor of 10 to the 40. So that's the answer to your question. Those things control whether what's anything can expand in their realm, and nothing can, because they gravity and dark energy don't have the ability to push against electromagnetism.
Got another dumb question that just kind of popped in my head. If that's cool.
No, dumb questions on my bread and butter. But
Awesome.
yeah,
So, is it possible that gravity isn't so much mass attracting mass, but like as space expands, there's like like the particles do separate, but there's like a like maybe an electromagnetic pull upon them that collapses it back, and then that's why everything like matter tends to congregate. Is that
no,
just like
no. Electromagnetism is all by itself, and rules things like planets. You know, but no, I'm sorry. Gravity rules things like planets, and and but once, so in other words, the 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 gravity pulls the planet together, so you get a place to stand on. But once you're standing on the planet, electromagnetism keeps you from falling through it. So the Earth is pretty strong. You weigh, I weigh 186 pounds, uh, and yet the floor can support me against the entire Earth pulling down. So
Pauli
electromagnetism
exclusion
is what's
principle?
keeping. What's that?
Is that Pauli exclusion principle? Like because
No, no,
electrons
no,
can't
no. It
be
has
in the
nothing to
same
do with.
energetic
No,
state?
no, no. Not Pauli exclusion. This is just electromagnetism is holding the molecules together. Okay, and 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 they're strong enough to hold me up. The floor is made up of wood. Wood is made up of molecules of cellulose, and the cellulose is keeping me from falling through the floor. And that's made of a chemical called cellulose, which is made up of atoms, which is uh, uh, molecules. So it's strong enough to hold me up against the entire Earth is struggling to pull me down, and a piece of floorboard holds me up. So gravity is very weak, right?
Wow, that
I'm not
was
sure.
great imagery.
Yeah, no, but I don't know that I answered your question at all.
Well, I'm sorry. I kind of like I'm at work right now, and I had to like take a call. So could you run that last part back one more time? Sorry about that.
Which part did you leave at when you took the call?
So the cellulose. So like the cellulose is
Oh,
made
I'm
out of
saying is
molecules.
saying cellulose is stronger than gravity. It's because it's held together by electromagnetic forces, which is 10 to the 40th times stronger than gravity. So gravity doesn't have a chance against cellulose.
Which I can understand that with gravity being like the weaker force, but then
Yeah,
again, like with the mass of the object, the overall pull. That's another question actually. So
yeah,
is it the more the mass, the more is pulling or
yeah,
attracting?
yeah. Although, in fact, of course, you know that ever since Einstein, that we we don't talk about gravity like a force anymore. You know, it's like bending space-time. So, you know, in truth, to be pure about it, it's not the gravitational force. It's the it's the fourth dimensional version of mass bends space-time so that things follow the geodesic defined by the shape of space-time. So when you throw a ball into the air, it's not falling because of the force of gravity, it's following the, the straight line defined by the shape of space-time in the vicinity of the Earth, which happens to be a parabola.
I'm not gonna lie, I am lost now. You had me until you got to the following space time.
Yeah, well, I did that just to confuse you because you know, you're talking about gravity and talking about forces, and I thought, well, I'll throw a monkey wrench in. Uh, No, really, it's there. You can find people who discuss the idea that gravity is not a force. It's not. It's a it's the influence of mass on space. So mass curves space-time, and objects that travel freely in space-time travel the least the path of least resistance through space-time. Like if you want to travel around the Earth, you don't travel through a space straight line. You travel around, you know, what they call a great circle, an arc. So a straight line on the Earth is in fact an arc, a circle around the Earth that in fact cuts through the center of the Earth to be true. Okay, that's space. That's the path of least resistance on the Earth. The path of least resistance in space-time, if you happen to be standing on the surface of the Earth and throw a ball up, is that's the straight that is space-time on the Earth. If you happen to go up further away from the Earth and you throw that same ball, guess what? It will go in a straight line. The closer you get to the Earth's surface, the more likely it is to follow something that looks kind of curvy. So you are mapping space-time as you throw that ball around.
Is it because you're rotating with the planet at
Yeah,
the
it has
same
nothing to
time?
do with rotating. No, I'm just talking about
No.
a static Earth that's not rotating. You'll get a parabola out of it, right? The further up you go, the less likely that parabola will look exactly like it looks on the surface of the Earth. That
So
that
if the Earth wasn't spherical, say if it was a square.
well, don't do that to me. Come on, I have no idea what you're.
It's not a flat Earth room, bro.
Well, no, that it wasn't a flat Earth question. Like, like, because like I'm just wondering like would the trajectory change like in retrospect to the shape,
Of
like 'cause you know
course.
there's like big rocks, like big
No,
asteroids and stuff
if you
like that.
make a square Earth, then that would, in fact. So look, watch the Earth. Guess what? I have a news for you. Earth's not round. Okay,
Right.
and neither is it an oblate spheroid. If you're going to say that next, it's not that either. Turns out that the Earth is full with all such things they've called mountains and valleys, and and although those things are relatively shallow, and in truth, an egg is rougher than the surface of the Earth. You know, if you look at it with if you magnified an egg, it would be much rougher than the surface of the Earth.
Oh,
But
that's interesting.
nevertheless, it's still the Earth is oddly shaped, and when you are doing orbits around the Earth for Earth satellites that, in fact, you care about, you literally use a very three-dimensional a map of the Earth, which takes into account continents and oceans and everything, uh, maybe even high tide for that matter, and to get the orbit. So the Earth is by no means round. So there you, if you want it, so it's not a square either, and so the orbits are not circular, nor elliptical to the nth degree. They're something close to that, an approximation of that. So, yeah, but just think about it, and this is fun. Uh, so you stand on on the Mount Everest, and you throw a ball, right? It goes a certain distance, which would go further than if you're standing on the surface of the Earth, where the gravity is greater. Okay, the further up you go, the less the gravity. But also, if you throw that ball with enough speed, it'll go further and further. And you know what? It's no longer going to travel a path of a parabola, but it's going to go further and further. And if you throw it far enough and hard enough, it's going to go around the Earth again and again and again and again. And it's called orbiting. So all you got to do is throw a ball, and it will fall around the Earth. That's what satellites do. They fall around the Earth. They are traveling in a straight line defined by the space-time curvature of the Earth. So they're not being pulled on by gravity. They're just moving in a geodesic straight line. So there's no force of gravity. Forget that. It's not real.
So is
I
that
mean,
like the same with rings, like planetary rings? They're just in orbit, like satellites, like
yeah,
kind of
no,
free
no, they
fall,
are.
but
They are.
around.
Yeah, no, but I mean, I'm fooling around with the word no gravity because, in fact, you can easily do the same thing and describe it with gravity. But that's only because Newton got it right to the first degree when he wrote his little story, Newton's theory of gravity, in 1600 more or less, and when we launched spacecrafts to distant planets, we used Newton's laws of motion, not Einstein's, because Einstein's defined things to the nth degree. We don't need to get that accurate.
Oh, that's interesting. Okay.
Yeah.
Hello, everybody. Yeah, what I want to ask and add is, I mean, you still now, if you want to plan a mission to Mars or to the moon or orbiting Earth or any planet, you still use Newton's law.
You use
You don't
Newton's law.
use the space-time curvature. Am I
No, of
right?
course not. Right. You don't. Because Newton's laws are so much easier. And you don't need Einstein to figure out how to get to the moon.
Right, right. So, I mean, whether in Clubhouse or YouTube or anywhere else, people are talking about things more theoretical. People talking about parallel universe, wormholes, black holes, and other things.
Good luck with that.
And I think we're still planning to get to the moon, which is just 1 second light,
1 light second away. Yeah. One and
right?
a half light
Which
seconds.
is
But yeah, I like that.
right. Yeah. So I mean, we still. I'd like more to talk about Newton's law and physics more than parallel universe and wormholes
Yeah, I
and
don't want to talk about parallel
dark
universes. I
dark
don't want to talk about
matter.
Rome. No. Yeah.
Yeah,
Right.
yeah.
Right. So what are you saying?
No, I'm saying. I mean, yeah. Space-time curvature, but we're still using Newton's law
Yeah.
and planning missions and
Oh yeah.
and building spacecrafts
Yeah.
and sending satellites.
Yeah.
Yeah,
Yeah. That's
yeah,
what we
that's
do.
all.
Yeah.
Well, is Newton and Einstein that antithetical to each other?
No, no, no. It's just you don't need it. Okay. Like uh, Mercury goes around the sun, right? And Mercury goes around the sun, and it travels around the sun in an ellipse. But and that's a law. That's Kepler's law of motion. Kepler's laws saying that objects travel around other objects in an ellipse. Turns out that while Mercury travels around the sun in an ellipse, the ellipse tends to rotate, precesses, if you will, uh, and and the precession of Mercury's orbit has been observed more than 100 years ago. And so they said, well, what's going on here? And so they said, well, oh, okay, well, Jupiter has something to do with it, and Saturn also, and maybe the Earth, and
Oh,
maybe,
orbits can orbit themselves?
no, no,
I
they
mean,
can be, no, I'm sorry, what did you understand?
that no, I know I didn't say it
No,
very
I
well,
said
but
the orbits can change
I didn't
from
realize that.
the ellipse changes its aspect. So it doesn't continue in the same ellipse. The ellipse itself rotates
That is
around the sun.
fascinating. I did not know that.
It's called precession of the ellipse of the ellipse. Anyway, so they sat around and they said, well, I can see that Mercury's orbit is changing. Let me explain that. And so they calculated even before there were computers, and when computers were human beings, what the influence of Jupiter and Saturn and all the other planets had on Mercury, and they came up short. The number was like 600, and they were missing by 40, which was enough to say we missed by 40. And how do you explain that? So when Einstein finally came up with his theory of theory of relativity, it came up with that extra 40 out of the 600 that was happening already to explain the extra itty bitty bit. So you need, so that's what Einstein's theory of general relativity is good for, the itty bitty bit that happens over hundreds of years, not the itty bitty bit that happens over the 5 years it takes to get to Jupiter.
Mm. Gotcha, gotcha.
So you don't need Einstein's theory for that. But you do need it when you have to explain how come the universe is expanding. Then you really need it. That's where Einstein comes into, gets his glory from. His theory, general theory of relativity, is such that it demands that the universe either expand or contract, but for it to remain constant, for it to in fact not expand or contract, you have to introduce a fudge factor to prevent it from doing that. So Einstein introduced a fudge factor in order to prevent it from doing that. So uh, Einstein's good with universes, but not so good with space travel. Shlomo, you haven't said anything, or James.
Yeah, I had a question about how long can astronauts stay on like at a moon base? Like, I'm thinking all the construction that's going to have to go on there. If you're going to build like a fuel station on the moon,
Hmm.
you're going to need a tank farm and a lot of
Hmm. All that's,
pipelines and fluid
yeah,
systems that you'll have to get welded and installed. And I'm just wondering how long can these workers stay up there? Obviously there'll be automation and machinery and whatnot
right,
that you'll try to automate it, but at some point there will have to be human elements there, I think. And
certainly.
how
So,
long?
so
What's the
well, how
reasonable
long
duration
have
of time?
how long have astronauts remained in orbit, weightless, without suffering any deleterious effects?
That's a
You know
good
what I mean?
question. What is the record? I
Well, the
would have
record
to.
is over a year.
Okay,
They sent they sent one of two twins up into orbit.
okay, I think I've heard of this. Yep.
Yeah, and he came back, and and he's not doing so well. his brain, his eyes, he's not doing so well,
Really?
and they consider the change permanent. I mean, he's surviving, of course, but you wouldn't want to do that unless you wanted to be a permanent guinea pig. So people on the moon spending a year there will probably suffer the similar fate,
Is it like
although nobody
radiation
knows.
sickness or something like that? Does he have
No, no,
radiation?
no. It's gravity. Your muscles atrophy. Your bones lose. Your bones lose calcium. Your eyes do weird things. Your brain does weird things. Uh, and on the moon, well, only 1/6 gravity, it probably won't help much. Though people don't know the answer to that.
Was the altitude or the height that the astronaut was at in orbit for a year, was that proportional to moon's gravity or was it less or more?
No, it was zero. So moon is
So
one
it was at
six.
zero.
Yeah.
Okay, so the astronaut in orbit was at zero gravity,
Right.
but the astronauts on the moon base might be at 1/6 Earth's gravity. So that's
That's right.
more gravity, so it'd have less of a deteriorating effect on the astronauts, right?
You could argue that, but you'd
Hmm.
have to argue that. There's no way of determining it until we go there.
Until we go there, of course.
Right. Right.
I think there's
You can't do 1/6 gravity on the Earth.
another argument is getting supplies to orbit is much easier than getting supplies to the moon. And supplies, maybe the most important thing is water.
Right.
So
Right.
that's a difficulty on the moon. It's easier to get to the orbit. The orbit can be only 100, 200 kilometers away from Earth's surface, but the moon is much further. And besides, landing to the moon is quite a difficulty, as you heard and you saw many spacecraft crashed while landing to the moon. While
Well,
on orbit, it's easier to be on
well,
orbit.
but if you think about it, it's hard, but it's not. Uh, Certainly, it's hard, but think about it. The Apollo astronauts landed on the moon 6 times with an extremely primitive computer program, which was literally hardwired into their machine, with incredibly small amount of memory and no ability to amp to change it on the fly. It was literally knitted into the computer. It was wired by hand. No such thing as random access memory. No such thing as memory that can be written and rewritten for the program. It was permanent. And they landed on the moon 6 times. They got it right 6 times. Okay, the spacecraft that don't make it to the moon, why don't they make it to the moon? Because they didn't spend $24 billion to get there. That's it. That's the answer.
Right.
Uh,
Right.
and,
Yeah.
and, and $24 billion in 1960s dollars, which means $100 billion or $200 billion today. They'd send a spacecraft. They spend a couple of $1 million to do it. So and they're small and there's no turning back. There's no fixing it on the way. So when we go to the moon, we're going to get it right on the first shot. There's no the computer is smart. And it's going to know how to do it, and it's not going to be a failure unless their engines fail. And we usually
And
have
are you
these.
talking about a human
Yeah, yeah,
spacecraft with humans,
yeah.
or
Because human spacecraft, yeah.
okay,
When
not
they
Uh,
the
land
autonomous?
spacecraft, if you spend more money, you're going to get it right. You know.
Which one is easier? Okay, which one is easier, landing to the moon with humans or with autonomous vehicles?
Well, humans, because you spend $1 million, you spent 100 times more. So you're going to get it right, and you're not going to take a chance and get it wrong. But I mean, the Israelis tried it and they almost made it. The Indians tried it; they did make it. I think the Chinese made it a few times and failed a few times. The Soviets have failed a few times. I think it's about 50-50 for autonomous spacecraft.
Yeah, Russia failed a couple of months ago. It was Luna 25, I think, the name of the space, and it crashed. Japan, it crashed four
Right,
months ago, and they will
right.
try next month, I think. So yeah, it was. I mean, it was very.
I mean,
Yeah, like
look,
50% chance.
think about this. What you do is you send a spacecraft with a bigger rocket, okay? And the spacecraft that's landing has the ability to say, oh, I think I won't do that. I'll come back. So if you just put enough fuel on so that you make sure that it doesn't do something stupid and it says, let me fix that, I'll come back and try it again. So give it more fuel and it will try again before it hits. So many ways to get it right if you spend more money. More money means bigger rocket. You take two. What did they built? The biggest rocket ever built was used to go to the moon. They don't use those rockets to launch things to the moon these days. They launch itty bitty spacecraft with nobody on board. It's so much smaller.
Oh,
Even
I
Elon
start.
Musk's even Elon Musk's spacecraft is going to go to the moon, but he's going to have to refuel in Earth orbit so he can get to the moon. And the astronauts are going to be waiting in lunar orbit for his spacecraft to arrive to take him to the surface of the moon. So it's going to have a
Oh,
whole lot of it's going to have a whole lot of fuel. It's going to be able to land and take off. It's going to have a lot of fuel on board.
Yeah, I think that's a business right there to having a station to refuel on orbit, and from there you go, whether to the moon or to other planets.
Right.
This is
So,
something will happen in the future. Seems like.
I think it's pretty cool what we've managed to land on Mars. I think I don't think we've made any mistakes recently in recent decades. We launched Curiosity and Perseverance, and we launched Spirit and Opportunity. We've launched Sojourner. What's it called? No, it's with Vikings, I think they were called. And other nations have tried and failed. Nobody, as far as I know, has soft landed on Mars at all, but besides ourselves.
hello.
Slomo,
Okay, so I've been waiting patiently.
go ahead.
First of
Go.
all, Doctor, it's been a few weeks since I've been here, as you know. Um, so, Dr. Laird, your skepticism, you might call it skepticism.
Yes.
I call it reality based on your research and information, not
No.
this the
No.
stupidity of humans that think that there's an area there, wherever it is in Nevada, and that they got secret vaults,
Yeah.
and
Right.
that people are flying overhead in the Bermuda Triangle, and American jet pilots see these aliens. This is all BS, and none of it is anything based on anything that is even remotely possible, never mind likely.
Right. I agree with you, but remember, I am expressing my opinion. I'm very well informed, but it's still my opinion.
Yeah,
And,
so here's where I want to ask you your opinion.
okay.
Well, from the information, firstly, when is the first time in not the 4 billion years, but in the recent billion years, never mind the 500,000 years you mentioned 20, 30 minutes ago.
Hmm.
When is that first time that this planet could have had previous civilizations equal or far, far more advanced than this cycle of sentient beings on this planet?
But it's generally agreed that we are the first. And we don't have to, we certainly won't be the last, uh, I believe, but we are the first, and there's no, because there's enough geological, remember, there's a lot of scientists running around loose on this planet, and nobody has found any evidence for prior civilizations. Nobody has ever found evidence for it. So the absence of evidence leads me to believe uh, that we are the first, and that is the generally accepted story. You can invent another story, but that's not acceptable, not accepted. Now, we will, when we destroy ourselves, the civilization that comes next will be at a loss for natural resources. It won't have any oil to play with. They probably won't be able to destroy themselves as readily as we can. So they may survive a much longer time, but not be able to raise their civilization to the level of destructiveness that we have. I
What
have the
is
same.
your
Yes.
what is your assessment of me? I don't know how to pronounce his name properly. You know him probably personally. Miku Katsu's assessment of that we are at zero, and if we don't enter level one of the five levels that he
Hmm.
postulates of development of this human of this sentient race that we are, um, that we won't survive for very much longer as a race.
I
That
agree with
have
that. I don't agree with him. I don't like him very much, but I agree with that. And I don't. He has his own way of thinking of things, and he's a very smart man, and he's very well educated, and he has a set of opinions that are well supported by his own education. But I don't necessarily agree with everything he says, but I do agree with that.
And you and how many people, which does not include me, and I don't think there might be another person here that is an associate of yours, understand the 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 full the meaning of of human beings, so number one, being so insignificant to the cosmos, um,
Say say
so,
that
so
again.
so that we are so insignificant
Oh yeah,
in
sure,
the cosmos
certainly.
of hundreds of billions of galaxies, stars in our galaxy,
Yeah.
and 1 to 2 trillion galaxies,
Mm-hmm.
and the immensity.
Mm-hmm.
I mean, even to comprehend that
Yes.
there are more
Yes.
stars than there are grains of sand on this whole planet,
Absolutely.
or never mind the enormity of the distances
Yes. Mm-hmm.
and the time involved since the creation of the supposed of this universe,
Right.
which might exist, might it could be a hologram. You can give me your opinions of that too.
I'm
Uh,
not. I'm
uh,
not. I don't love it, and so no, I don't like it. But go ahead. That's because I don't understand it. But anyway,
Okay, but you understand far more than 99% of people that we are not two dimensional. We're not three. The universe is to us we perceive a three dimensional time reality, but to those like you, I assume, have an intuition, have an understanding more than I would of what the four dimension reality is. If it is
I
that there is space and time.
thank you. Uh, I agree. I know a lot. I don't know what your question is, if you have one.
Can you even try to explain in very simple terms space and time?
I think
Uh,
what you have done by listing those facts that you've gone through a set of facts, and everything you've said is accurate. But I don't think that I can begin to try to give you any better sense of the universe than you already have, since you already have named the names and named the numbers. Those are the important numbers. The trillions of galaxies, the billions of stars, the billions of planets that could be in our own galaxy that could be inhabited, you know, by intelligent life, perhaps. You know, we wouldn't know. Uh, so we don't know whether the billions have been habited in, or in fact, billions, or there's only one, and it's us. We don't know. So the majesty is amazing, but I can't give you a better sense of it than you already have with these beautiful pictures you have of the brain and all the gears that you've got there. It's cute. So
Great.
thank you for the
Uh,
compliment, but I have
uh,
nothing to add.
I'll have more questions for you to discuss next week.
Okay, that's good. Uh, Let me say that it is getting close to the time that I normally close the room. So anybody in the audience who has not asked a question and wants to, you can raise your hand. I'll bring you to the room. And the people in the on the stage, if you have more to ask, please go ahead.
I have one that I think will be rather quick. Like we talk about like the Hubble sphere, the visible universe, and you also talk about like the expanding universe. Like, are there galaxies in the very far edges that we've seen that have slipped beyond that Hubble sphere into the unseen that we've noticed?
When you say the Hubble sphere, there's actually there's a word that there's a word, Hubble sphere, and are you using it accurately? Do you think?
I'm gonna guess no based on your question.
Okay, so let's let me so the universe. according to uh, the latest word, is has a radius of 46 billion light years. That's not the whole universe, it's the observable universe. Okay?
Yes, that's more
Okay,
what I
so that means that 46 billion light years away, we are capable theoretically of seeing the light that was emitted from something at the earliest moment in time, and it could be reaching us now,
meant.
uh, at this moment, and it would come from 46 billion light years away. But there's another radius that's 16 billion light years, and that is that the light from more than 16 billion years ago, away that is emitted today will never reach us. That's the Hubble sphere.
Oh, okay.
So
All
light
right.
is getting from further away, but new light doesn't get to come to us. So if the universe disappeared right now suddenly by magic beyond 16 billion light years from here, we would never know, ever.
Hmm.
Because all the light we ever see is the light that's coming right here, right now, and it's in our vicinity, about to make its way to our eyes. But the light that's left beyond 16 billion light years is never going to make it to here. Because the universe is expanding. That's why.
That was great. That actually answered my question much more eloquently than than I could have hoped.
I have a
Right.
I
Yes.
have a quick question.
Yes,
If
James.
the universe is expanding, does that mean a plank is expanding too as well?
A
Is that
plank, you mean
getting
a plank of wood?
no, the smallest unit, measurable unit of
No. Uh, oh, hmm. Uh,
Planck's
you're
constant.
asking a different question than the question somebody asked earlier, which was, uh, does do atoms expand?
right.
And
And
the
then
answer,
I guess I started thinking about planks then and like the
right,
smallest unit.
but then the smallest unit would still be the smallest unit. In other words,
Okay.
maybe the smallest unit today will be still a Planck constant. The numbers won't change, as far as I know. It's defined by other quantities. Or no, it's a number. Uh, I don't know the answer to your question, but I think the answer is no, it won't change.
Yeah, because isn't like a plank like a tetrahedron or something like that? It's like a
No. It's a distance. It's a distance. It's a number, 10 to the minus 34, something like that,
oh, okay.
centimeters.
I
And
interesting.
so I don't know to what extent that would change, based upon, uh, how you define length and stuff like that.
Right, because if the universe is expanding and that stays constant, that's kind of interesting. Is that a point of reference of some sort or something? Or
Well, it comes out of, uh, for instance, an atom produces when an electron drops from one level to another in an atom, it produces a wavelength, a certain amount of energy, and that energy is equal to the Planck constant times the frequency of the light, and and the energy is not going to change, and so and the frequency is not going to change. So I guess the Planck constant is not going to change. I mean, I don't. That's all I got.
no, that's different. Yeah, that because that makes a difference. It's just a frequency, so it's not necessarily even related to like expansion of universe.
Right. It has to do with electromagnetism, and electromagnetism isn't going to change as the universe is expanding, because
Hmm.
expansion has to do with gravity, and this has to do with electromagnetism, and they're different forces. So I guess the answer is no, it won't change.
Interesting. Thanks for clarifying that.
I'm not clarifying. I'm guessing.
You did better than I could, so thank you. I appreciate it.
Okay, good. All right. So listen, Haris, because you are a moderator, uh, what you need to do is when I end the room, which is going to be shortly, uh, you will still be there and the room will still continue unless you also end it. You see? So that
Oh,
is,
we have to
yeah,
we
so we
have
have to
to
end it
end it
pretty
together.
much together, right? And if you
I
choose
did
to
not know.
not end it, then you'll be moderator and you'll be in charge of ask Dr. Laird you stupid astronomy questions, and you'll be the one having to answer it. So so you should
They'll get
definitely
some real stupid responses.
right. So listen. Do check out my YouTube videos. They're up there on YouTube. Laird Whitehill is my last name. You can see me talking for 42 hours at least. Uh, See what I look like in person. Uh, and you can go to my website, and it's lairdwh at .com, and you can even find a couple of things on Zip, no, what do you call it? TikTok, fun. You can find me on TikTok as Laird WH on TikTok, and Laird Whitehill on YouTube, and please enjoy yourself if you want to go there, and otherwise I'll see.
Did you end the room already on your end, Laird?
I fell off. I fell out of here again, but this time I got back faster. Okay, what I was saying is I'll see you next week if you care to come. Tuesdays, 11 o'clock Eastern time, New York time. And then, so Harry's, let's end the room together, shall we?
Okay.
We'll count down from 10. At 0, we will leave quietly and the room will end.
Sounds good, my friend.
Okay, good. All right. So 10 and 9,
9, 8,
8, 7,
7,
6,
6,
5,
5,
4,
4,
3,
3,
2,
2,
1,
1,
0.
0.